Ever stare at the screen wondering if starting over is even possible? I did. I'm Enrique, a former business owner turned into an aspiring software developer. This channel isn't just for coding problems, it's about rebuilding ourselves, one script at a time. Let's engineer solutions that make useful unforgettable. Subscribe, not for perfect code, but for progress that feels human. Alright, welcome back everyone. We are solving today another LeetCode problem. And based on the list we've been following for the past, I think, 2 or 3 videos, we're doing grind 75, but we're basing all that problem solving on the new tool. This tool is basically actually pretty cool, by the same creator of grind 75. Is basically you can type input and schedule, right? So you calculate how many weeks and hours you can work per week, and it would generate an amount of questions that are, sorted by topics and difficulties and so on and so forth. It shows you here like a quick question summary. For my type of preparation, like I calculated like just 20 weeks by 20 hours per week. I started this, I don't know, like 3 or 4 months ago, using different lists, right? I went back and forth between LeetCode and NeetCode and grind 75 and some other list, right? But anyways, I hope this works for you. Try it out. If you're looking for a resource to keep your problem solving by a list, organized by a list, this is a way to do it. Some people don't like to do it like that. You find your best option, right? You stick to it. That's the most important part. You stick to it. All right. So for the questions today, we're supposed to solve 3 sum, right? But I recommend you check the previous video, because on that video I solved the problem of insert interval. Now, I also mentioned that some resources online recommend to solve merge interval before you solve insert interval. I did it backwards because I obviously came here from the list, and merge interval is all the way here in 7th. But today I want to do a little bit of DFS, in a sense of not the problem. I don't think merge interval, we're going to need DFS. I don't think it's even a tree structure. But in terms of my study, I want to go deep in a particular topic, especially when they're like medium questions, they're too close together. You have a little bit of the code in your head, you're fresh, you want to come out and just put the code and see if it works, right? See if your intuition, you can pair things together. I hope that makes sense. But anyways, again, this is a process of being honest with yourself. This is a process of learning. There's a lot of geniuses out there that are going to be criticizing what you do, or obviously some people are extremely great at these things. That's not what we're aiming for. If you're one of those geniuses that are here to criticize, you can feel free to do it, okay? But I'm really not trying to chase you here. This is not a race against the best developer. This is a person that's coming from a business background, transitioning into a tech background, right? I have a little bit of knowledge on technology. I have a little bit of knowledge on certain things, but obviously this career is learning all the time. Every single day you're learning something different. It doesn't matter who you are. So that's the main purpose of this kind of videos. You're going to see me make mistakes while I code, while I explain the problem. Some aha moments would come to my head, and I would try to include that. Just being completely open, right? Also, this serves as a way for me to practice my problem speaking out loud, right? That's important for your interviews. At the time of your interview, you're going to have to explain the way you're thinking, processing the problem, right? So that's also a thing I like to do in these videos. It's not perfect by any means, but it's honest, and as long as you stick to it, there's no other way. There's no other way. So let's go ahead and jump into merge intervals. They recommend here after you practice this problem a few times, you should be able to solve in 30 minutes. I think we can do it in less. since we have the insert interval problem fresh in our memory. And I really think we are going to be able to do it in less, right? We can start the timer here. I'm going to do it as soon as I read the problem, as soon as I kind of inspect everything and see that, and then start the timer. If we want to be like interview style, we can start the timer right now, and based on what we read and everything, we can see in how long we can do this problem. But once you start hitting a couple medium questions, it's good to time yourself. It's good to see how long it's taking you to get some of these concepts. Once you feel like you're kind of giving up on it, you can pause the timer and start back, start refreshing all the basic stuff that you need to learn before you start timing yourself. Let's jump right into it, okay? Enough talking. Given an array intervals where intervals at that index I, it's equal to a starting time and an ending time. An array, right, of starting and ending intervals. Merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. All of them. Kind of like a short description, very open-ended question, a lot of things to infer here. A good thing to notice here is that on insert intervals, which to go check that video, the list is sorted, right? We don't see the list is sorted here, which I see that on the examples, the problem, like the examples they're giving us, are sorted by starting time, right? Which is the most important thing when you're solving intervals. Again, go back and read some of this, the Tech Interview Handbook. It's a pretty good website to start. I was reading all this before I solved the problem, obviously not trying to memorize any particular code or anything, just to get intuition, just see how things are panning out in this problem. So that's the first I would say hint we get, right? We don't see that it's mentioning that the list is sorted, even though the examples are sorted here, but it's not saying it, so we can't really assume anything in this case, right? So, okay, there's no any weird constraints, every interval, it's going to be a huge number. Basically, list can be anywhere between those intervals. The length of the interval, meaning each number here, it's going to be a 2-digit number, so anywhere from 0 or 1 all the way up to 99, I assume. And start and end. Okay, no. Intervals of I. No, never mind. This, the array inside the interval, it's going to contain only 2 elements, starting point and an ending point. Now, that start point and that ending point can be a huge number too, basically a 32-bit integer. I believe that's what's 10 to the 4 here. Gotta do a refresh on that, but yeah, I believe so. So anyways, start and end for each interval in the main interval array. We see here that this is a list of list or a 2D array where we have list inside of list. So we have to think about that at the time of solving the problem. Let's jump right into it. I'm gonna bring my whiteboard over here, which in this case is a blackboard. Just a funny fact. In Spanish, when you're learning English, they call all these things that you can write on and erase, right? They call it green boards. And you're learning English, and then you start seeing like a whiteboard or different colors whiteboards, right? They're all like whiteboards, but not necessarily they're all white, right? I know it's kind of dumb, but in Spanish they call it green boards. I don't know why. I assume it's the one used to like have back in the days in school would use the chalk and stuff. But anyways, that's just a fun thing when you're learning a different language. But we have let's get this thing on. let's see here. We have, let's see, we have this and this interval. I'm gonna try to bring this up here so I can copy on this side and still see my inputs. So we have an array of intervals that's gonna be equal to, let's see here. We have 1 and 3. We also have 2 and 6. We also have 8 and 10. And 15 and 18, right? So this is our input array. And okay, so we're not assuming that this is sorted, right? In this case, this particular case, this array is sorted. So I'm going to assume, I'm going to delete all these because I want to assume that I'm getting a non-sorted array because it's not being specified in this question, and that would also be your first question if you get this question in an interview. Or it would be my first question. It's like, is the input array sorted? Can we get an insight on that? Is it sorted? What's the deal with this array? Because I see the examples are not necessarily sorted. But anyways, let's move on. Let's say we have 8 and 10 as our first number. Then let's say we have 2 and 6. Let's say we have now 15 and 18. And now we have 1 and 3, right? We're just shuffling things around just to make sure. So the first thing, right? Immediately, since we know we have a non-sorted array, we know we can run into great times in terms of asymptotic analysis or time complexity, right? In the sense of we need to return overlapping intervals. Overlapping intervals are intervals that are naturally connected, right? So if we have 2 and we have, let's say, 6 here, right? From 2 to 6, if we imagine that we have a straight line right here from 2 to 6, say 2 starts here, 6 ends here, we have a bunch of intervals, 3, 4, and 5, that go before our ending interval, right? So we know that the first thing we need to do, since we have to return all those intervals, it's sorting, because that's the only way we're going to be able to find everything that's between these lines here, right? So let's say, for instance, let's say we have 2 and 6 again. I'm just going to do this quick example here. I'm trying to go over this concept, and again, it's a little fresh in my head since I was solving insert intervals in the previous video. So we have 2 and 6, and we said, you know, 2, I'm gonna put 2 here in this time, I'm gonna put 6 here, but we also have 1 and 3 right here. So in order for us to find this interval, so I'm gonna put 3 somewhere around here. So 1 and 3, let's say this interval starts and then here, and this other interval goes from 2 to 6. Oops, that line, it's trying to be straight, it's not coming up. There we go. So anything that overlaps, it's obviously anything that interfere here, it's obviously an overlap. So in order for us to we see here we have 2 different intervals, 1 and 3 and 2 and 6. So in order for us to find this, we first need to sort by starting point, right? Because we need to connect these intervals in order, right? So order, obviously ascending order, obviously will be determined by the starting point here, right? Of all these values. Now this problem would get a lot more complicated if these values here would be swapped. I hope that makes sense. Like if we would have to sort these values inside first, and then we would have to work on the list, that would be another, let's say, another level to this problem. But hopefully for this problem we don't have to do that, so we can go ahead and start working with our problem. So sorting, it's going to add, basically we're using Python, so pretty much on any language this type of sorting algorithms are n log n, so that's going to be basically our greater time complexity so far. And hopefully if we sort everything, we can go over the array now in linear time, and we can keep everything under this running time, right? That's what we want to aim for. Obviously it would be nice if we could do it in linear time instead of, you know, logarithmic linear time, but we have to sort the list, and that would add a little bit of complexity to it. So how would this array look after we sort it? Let's work with that. After we sort this array, let's do it just right here. I'm gonna say, actually I'm gonna keep the time complexity there just to remind, and log in, just to remind ourselves what we're working with. And if we run into other things later on, we can maybe go back to it and see if our time complexity will expand. So sorting this array, this is what we would get. 8 and 10 and 15 and 18. So this is after we sort, right? And we are already running into n log n time. So now we have the array. What's the next thing it's asking for? Well, it's saying you need to return an array of non-overlapping intervals. So we could go down into a rabbit hole trying to see if we can solve this without having to create a new array. But the simple fact that we are sorting in Python, specifically, there are two ways to sort this, and it would be using, and I'm gonna go into code later, but it would be using sort. Where we say, you know, the array dot sort. So basically it would be array dot sort, and we can pass a temporary lambda function and sort by starting time, or we can just create a copy of the array and say that that's equal to the sorted array, right? It would be like sorted using the sorted method in Python. I believe sorted and sort, I believe these two methods, I'm not 100% sure, I should know this, but I think they're both team sort, which is obviously a combination between two sorting methods. So it would be sorted of n, which is the same array, right? Those are two ways. I just wanted to kind of go over that, so not leave that hanging. But again, I forget I'm tracking this problem. We're already in 12 minutes, so I gotta explain this thing. Let's go ahead and see how we can go over this. So let's say we're gonna create a new array, right? We're not gonna go and I'm gonna call these merged, because that's what I call the last array in my insert interval problems, which I recommend you to go and check it out. Basically we merge, the way we merge is making these values here dynamic. So these values right here, their start and ending time, are going to be manipulated in a dynamic way, so we could always get the values that overlap and expand our actual interval, right? That's what we're aiming for. So the first condition would be to check if the merge list is empty, right? Because if it's empty and our array is already sorted, we don't have to worry about order. If it's sorted already and our list is empty, we can just go ahead and immediately add our first item in the array to our merge list, or our new merge array, because that would be a good starting point, right? It's already sorted. We don't have to worry about overlapping intervals before this point because we did our due diligence on sorting the array. If the array would be unsorted and we try to apply that logic, let's say the merge array is empty and we try to say, you know, if it's empty, go ahead and append our first array. Well, we would run into problems because in this case, that's not the smallest array, right? We would have to sort this list here. So that would be a little more complex than just sorting your input list, right? So going back to this, if our list is empty, let's go ahead and add our first term. Another condition we could check is, since this is the ending part of the array, let me change colors here real quick. Since this is the ending of the array, we want to check if there's an overlap, right? We know they're in order, in ascending order, right? So all this is ascending order, and we know that we're gonna find overlaps. Well, the overlap is going to happen if our ending time is still running while our starting time of the next overlap interval, it's just started. Let me just explain that again. If the ending time of my actual interval, the one in our merge list that goes before our next interval, if my ending time is greater than my starting time up to the right in terms of ascending order, that means these two interval overlaps because this interval hasn't finished running and this interval just started, right? So this interval just started at 2 and this interval hasn't stopped running. So again, a good way to visualize this is using a line of numbers and having your, this obviously not going to be perfect, but I want to explain this. 1, 2, 3, 4, and 5. Let's do 6 over here. And we have 1 and 3 starting here, and we have 2 and 6 all the way here. So again, we see that our first interval that started over here ends all the way here, but we have a second interval that just started and we haven't finished. So all this area is overlapping. Again, we check that by asking if our end time in our current interval in the merge list that goes before, because we sort it, ends after this interval started, right? Okay, so that's how we're going to ask that. We're going to say, if that's the case, then what do I want? Okay, what I want is to merge these two intervals. And how do I do that? Well, I know I have the smaller starting time already because the list is sorted. So since the list is sorted, I don't need to get the starting time of this interval because I already know I have the minimum possible interval starting time. So what do I actually need is the greatest ending time, the biggest ending time between these two, because I want to merge my smallest starting point with my greatest ending point. So again, I make this array dynamic. On my second iteration, this value becomes 1 and 6 because my ending time is not less than my starting time. In fact, it's greater, right? So if it is greater, meaning there is an overlap. That's what determines what's an overlap. Overlap happens when my ending time is greater than my starting time. Okay, so on different intervals, this is, imagine this is A, imagine this is B, and we say when A is less than B, meaning if this value would be smaller than this, there's no overlap. But since that's not the case, because A is greater than B, then there is an overlap. and we automatically go and get our greatest value. So we keep moving. We already checked these two right here. We move on to the next one. The next one asks the same question. What's the question? Well, the question is, it's my ending time here less than the starting time here. And look, in this case, it is, meaning this interval already finished running my line. My interval ended here at 6, and I have 8 right here. So there's no overlapping. So what do? Well, if that's the case, that's easy. We go ahead and add that to our list because we're done merging. We ask the same question. We move into the next iteration and we say, it's our ending time here smaller than the starting time. Correct. There's no overlap. And we add our 15 and 18. And that's how we're going to do that, okay? That is our resulting ending array. We return that. And as we see here on the left side, 1 and 6, 8 and 8, 8 and 10, 15 and 18. And that's exactly what we have here. And that's the way we're going to walk it through, okay? So we have 20 minutes already. But obviously, this is going back and forth explaining the problem. The way we could do this is, okay. So let's think about a few things. First, we are going to need to sort the array. That's the first thing we're going to say. So I'm going to say intervals. I'm just going to keep like that. Intervals, it's equal to sorted intervals. And I want to use a method here that's going to sort these items by the starting point. Okay, my index 0. Perfect. So we're sorting the list. This is a custom sort we're doing. We're sorting all the elements by their starting position. Since the positions are sorted already within the particular interval, we know it's going to be order in ascending order, right? The next thing we need to do is for any interval, we're going to iterate over this list. We're not necessarily going to need indexes until we have to manipulate that last item, right? So for any interval in intervals, we know our list is already sorted. That's all we're going to need there. We're going to say if, okay, so again, we need to create a merge empty array. That's the next step. So we sort our list and we create a new array. And if this array is empty, or what other condition they would say, well, if the array is empty or the last item at our last index, meaning that this value right here, this is how we get this value right here, right? That would be the last array, the last element of the last array, right? Is less than our actual interval at position 0, meaning the starting point. That's how we get this starting point right here, right? So we're saying if the list is empty, which is going to be for this first example here, go ahead and add it here. Now compare this ending value with the starting value. If this value is less, then go ahead and add this value. If not, then there's an overlap, okay? So if the list is empty or our ending value is smaller, then we just simply add that interval to the merged list. Okay, so that is how we're gonna do that. Now, if that's not the case, then we need to modify our merge last interval and get the maximum value between this same value right here. Actually, I want the maximum value between my actual interval and my interval at 1. On the maximum value between these two, as you see here, I'm basically updating that value. I'm calling that last value and updating its value to the to the greatest element between these two values. Whoever is greater, so basically going back to kind of like a mess here now, but let's see if I can delete a few things. Okay, so what we're doing here is saying, you know, since this value is already greater than this value, go ahead and update this value with the greatest between these two. The same question happens if I would have an overlap here. Okay, because I want this value to be the greatest, and that's how we're going to merge our intervals. When all that's said and done, our merge value gets updated, and honestly all we have to do is return our merge array, and that should be it. I want to call it, I'm going to run it and then call it hope that, okay, for interval, oh Jesus, interval and intervals. I was trying to do it before 25 minutes, but anyways, yeah, that passes those two test cases. I'm going to stop time right now, submit, right? I'm going to give myself some grace because I spent a lot of time explaining the problem, which you would probably spend that same amount of time dissecting the problem for the first time and going down with the interviewer, asking questions depending on the style of the interviewer, if they want to give you enough hints or whatever. But I'm gonna run this code and hope everything runs good and perfect. Wow, I wasn't expecting that low of a, but perfect, yeah. So if we check here, this is a cool function actually. I don't know how many times you can use it on the free plan, but if we check our time complexity, we see is and log in because our sorting time obviously, you know, came into play, but that is for now good. And yeah, we're done with that problem. Let's get that confetti going. No, I think confetti is this way. I don't know if it's gonna show confetti. Nope, no confetti. All right, well, forget about that. Just scratch confetti. But yeah, that's how you solve merge intervals medium problems. So pretty cool. I hope you guys enjoyed this video, and let's check the next video. I wanted to mention real quick before I go, if you want to have this spreadsheet I'm using to track algorithms and key insights for each problem, let me know. It's kind of useful. So for this problem, as you can see here, the trick or algorithm we have to do is custom sort by starting time, and then do a linear scan of our arrays. Sort intervals by start time, then merge overlapping intervals in one pass. That's kind of like useful if you want to do like flashcards and stuff like that. But yeah, that's everything. I hope you liked the video. Subscribe, follow my journey, subscribe and like the video if you like it. And yeah, that's about it.